Today we're going to go over a chapter that I skipped. It's chapter 1.4, Reasoning and Proof. I'm not going to go over the entire chapter because there are some things in this chapter that are not necessary to go over. I'm only going to go over the important stuff that we need to cover. Okay, first we're going to go over a couple of definitions. Some of them you might remember from middle school. First of all, parallel lines. Parallel lines are two lines that are coplanar and are always equidistant at all points. Coplanar, I wrote right here in parentheses what coplanar means. Coplanar means that they lie in the same plane. And they're always equidistant. Okay, the word equidistant contains the word equal and distant. Alright, so the distance is always the same at all points. So if you look at these parallel lines, they're always the same distance from each other at all points. Same with this pair of parallel lines. Parallel lines always stay the same distance from each other, and they never intersect. They never touch. They never intersect, because they're going to keep going into infinity in both directions, staying the same distance from each other. Those are parallel lines. Now let's look at perpendicular lines. Perpendicular lines are two lines that intersect at 90-degree angles. So two lines that intersect and they form 90-degree angles everywhere here. All four of these angles are 90-degree angles. Same here. All four of these angles are 90-degree angles. That's what those little boxes tell us. Those are perpendicular lines. Two other definitions that you may remember from middle school are complementary angles and supplementary angles. Complementary angles are angles that when you add them up equal 90 degrees. Here's an example. A 52-degree angle plus a 38-degree angle would equal 90 degrees, so those angles are complementary angles. Supplementary angles are angles that up to 180 degrees. And remember that 180 degrees forms a straight line. A straight line always measures 180 degrees, 180 degrees. The way that I always tell students that you could remember which is that the letter C comes before the letter S in the alphabet, just like the number 90 comes before the number 180. So the ones that add up to 90 degrees are complementary. The ones that add up to 180 degrees are supplementary. That's an easy way to remember which is which. The ones that we're going to be dealing with today, though, are supplementary angles, which form a straight line. So let's look at those a second. Okay, so two angles whose measures add up to 180 degrees are called supplementary angles. Now, there's a very important term here that we got to look at, which is a linear pair. This term, if you look at the words tell you what it means. A pair means two, and they're going to form a line, because linear has the word line in it. So it's a pair of angles that form a straight line, which is what you're seeing here. A linear pair is when you have a pair of angles that together form a straight line. And remember that a straight line always equals 180 degrees. That's why here it's telling you that the measure of angle 3 plus the measure of angle 4 has to equal 180 degrees, because a straight line always equals 180 degrees and supplementary angles always equal 180 degrees. Now let's look at the full definition so I could show you another word here. To be a linear pair, they have to be a pair of adjacent angles. Adjacent angles. You may not be familiar with that word, adjacent. Let me tell you what it means, because it's going to come up a lot, so try to remember. Adjacent means next to. Adjacent angles means angles that are next to each other. So to be a linear pair, it's two angles that are next to each other that add up to 180 degrees. Or said a better way, two angles that are next to each other that form a straight line. Two angles that are next to each other that form a straight line. And because a straight line always measures 180 degrees, that means that a linear pair always adds up to 180 degrees. They always got to be supplementary angles. Okay, and just to continue the definition, it says a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Whose non-common sides are opposite rays. So if you look down here, the side that they have in common, is this one right here. The definition says that they're non-common sides. The ones that they don't have in common, which would mean this side as well as this side. Okay, the non-common sides are opposite rays because they're rays going into opposite directions. Sorry for my messy lines, but the sides that they do not have in common, which would be this one right here and this one right here, they are opposite rays. Really, the main thing you have to remember is that there are two angles that are next to each other that form a straight line. The word tells you what it means, a linear pair. A pair of angles that form a line, a straight line. Okay, now in a moment we're going to look at problems that use these three different postulates. We've already seen them, and in an upcoming slide I'm going to refresh your memory what they stand for. But basically there's three postulates that we're going to use today. The linear pair theorem, the segment addition postulate, and the angle addition postulate. Let's look at them and I'll show you which one goes with which problem. It's extremely simple. Let me just get to a problem so we could see. Okay, here's our first example. Use a postulate or theorem to find the value of x in each figure. Okay, now since this involves segments, you have this segment RS, that you add to segment ST in order to form the entire segment RT. We're talking about the segment addition postulate. Alright, and you know what? If that sounds complicated, let's just look at the math. Forget about the words for 1 second. Let's just look at the math and it'll make more sense. Okay, so the question is, we got to solve for x. Okay, they want us to find the value of x in each figure. That's what it says here. Find the value of x. Okay, so look, they're giving us this information. Given that RT equals this, RT is the entire thing. Starting here all the way to here, the entire thing is 5x minus 12. That's what it's saying down here, that the distance from R to T is 5x minus 12. Okay, the distance from R to T, if you look right here, the distance from R to T, or the length of segment RT, has to equal the length of segment RS plus the length of segment ST. Again, the length of the entire thing, which is RT, has to equal the length of this segment, which is segment RS, plus the length of this segment, which is segment ST. So they're setting it up this way. This is what they're going to do. RS plus ST has to equal RT. And then right here, they're just substituting. Okay? The length of RS is this, plus the length of ST, which is this, has to equal the length of the entire thing, which is this. That's how they set up their equation. Alright? I'll do the same thing right here. X plus 2 plus 3x minus 8 equals 5x minus 12. Okay, now in order to solve this, the first thing I have to do is combine like terms. Combine like terms. That means I'm going to add all the terms that have the same variable in the back. All the terms that have an x in the back. So remember, there's an invisible 1 in front of this x. So 1x plus 3x is going to give me 4x. Okay, now that I got rid of this, and I got rid of this one, okay, I'm going to deal with the numbers that do not have a variable. Positive 2 minus 8 is going to give me negative 6. Positive 2 minus 8 equals negative 6. The right side of the equation I have not touched yet. So now I just got to get all the variables with all the terms that have x on one side and all the terms that do not have x on the other side. Since I like to keep the number in front of x positive, I'm going to move 4x to the right by subtracting it from both sides of the equation. Right here, this is going to cancel out because that'll give me 0. This will give me 1x, and I don't write the 1. Now, since I have the x on the right-hand side of the equation, I'm going to move the minus 12 to the left-hand side of the equation by doing the opposite of subtracting 12, which is adding 12 to both sides. Right here, this is going to cancel out because negative 12 plus 12 is 0. And over here, negative 6 plus 12 is positive 6. And there's my answer. X equals 6 is the answer. Let me do another example like that. Now we're going to look at another example. Okay, now in this example here, it says at the top, given that the measure of angle RST equals 15x minus 10 degrees. So this entire angle, the entire thing, okay, angle RST, the entire thing is equal to 15x minus 10 degrees. So the way you're going to set this up is that this one, this little angle right here, plus this little angle right here has to equal what the entire thing equals. Again, this little one plus this little one has to equal what the entire thing equals. So one way that you could set it up, which I'll write it up here, is x plus 25. That's this one right here. Plus 5x plus 10 has to equal what the entire thing is, which it says on the top. The entire thing, the measure of angle RST, equals 15x minus 10. If you understood that, that's all we're doing. I'm setting up that this little one plus this little one has to equal what the entire angle equals. Okay? Now let me just do it using the template that the textbook is providing. First of all, they want to know what postulate I'm using to figure this out. Okay? Your homework is multiple choice. And it's easy to figure out which is which because all you got to do is look at what does this problem involve. It involves adding angles. So it's the angle addition postulate. The angle addition postulate. The one we did in the previous slide right before this one was the segment addition postulate. How did I know that? Because it involved adding segments. This one involves adding angles. Okay? So the way they're setting it up is that the measure of angle RST, that's the entire angle, the big one. The entire angle RST has to equal the measure of angle RSP plus the measure of angle PST. That's this little one right here plus this little one right here. And now we're just going to substitute. The measure of angle RST, it says it at the top that it equals 15x minus 10. The measure of angle RSP is x plus 25. And the measure of angle PST is 5x plus 10. Okay, now, first thing I'm going to do is combine like terms. So on the right hand side, I'm going to add this x plus 5x. Remember, there's an invisible one here. So 1x plus 5x is 6x. And now I'm going to add the 25 plus the 10, which is going to give me 35. Okay, now we got to get all the terms that have the variable x in the back on one side. So I'm going to move 6x to the left by subtracting 6x from both sides. So minus 6x minus 6x. And I'm going to move the minus 10 to the right by adding 10 to both sides. When I do that, I'm going to get on the left hand side 9x. The x is already there, so I don't need to write it. 9x equals, on this side I'm going to get 45. So to get my final answer, I'm going to write it here because there's not enough space. I move the 9 and put it beneath the 45. 45 divided by 9, okay, which is going to give you x equals 5. And that would be my answer. X equals 5. And there's the answer from the book. I'll upload the PowerPoint to our Microsoft Teams page. Let's do another example. All right, let's look at this one. You're going to have problems like this on your homework. Okay, it says, and I want you to see how I'm going to draw it. You don't have to draw it, but it helps to visualize it. If you could do a little sketch, it helps to understand what to do in this problem. It says that point E is between points D and F. All right, let's stop right there. Let's just look at that part. Point E is between points D and F. All right, look. Point E, it doesn't have to be in the middle. If you want to put it in the middle, put it in the middle. If you want to put it off to the side, we really don't know if it's in the middle or to the left or to the right. Let's just put it like that, but it doesn't really matter. What matters is that you understand that point E is between points D and F. You don't have to know how to draw to draw what I just drew, okay? That's pretty simple. Now it says if DE is equal to x minus 4, okay? Let's sketch that. DE, let me put it up here. DE is x minus 4. Okay, so that's that part right there. EF equals 2x plus 5. EF right here equals 2x plus 5. And DF, that's the entire thing. Let me go like this. DF, the entire thing is 4x minus 8. Okay, now we got to solve for x. Find out what x equals. Alright, so the way I'm going to set it up is this segment plus this segment has to equal the entire thing. Alright, so x minus 4, or you know what, I'm sorry, before I write that, let me just write this on the top. Segment DE plus segment EF has to equal segment DF. That's what I'm doing. Alright, so segment DE, it says is x minus 4. Okay, now segment EF is 2x plus 5. So I'm going to add it with that segment. And when I add them, the whole thing has to equal 4x minus 8. Because that's what segment DF equals, 4x minus 8. Okay, so now I'm going to follow the same process and combine like terms. So first I'm going to add x plus 2x, and that's going to give me 3x. Then I'm going to add the negative 4 plus 5. Negative 4 plus 5 equals positive 1. Negative 4 plus 5 equals positive 1. On the right hand side, I still have 4x minus 8. Now I want to get all the terms that have the x in the back on one side and all the terms that do not to the other side. So since I want to keep the number in front of x positive, I'm going to move 3x to the right by subtracting from both sides. Alright, this part will cancel out. On this part I'll get 1x, and I don't write the 1, so it's just x. And I'm going to move the minus 8 to the left by adding 8 to both sides. So there's my answer. Always read it starting with the variable. X equals 9. Don't say 9 equals x, because that doesn't make sense. It's x equals 9. And it makes more sense to write the answer like that. X equals 9. Okay, let's do another one. Okay, now it says y is the midpoint of segment XZ. Alright, now this is important because they're telling you that y is the midpoint. It's exactly in the middle. If they wrote that, it's for a reason. They're not just putting that if it's not important. Okay, so here's segment XZ. Y is the midpoint. It's exactly in the middle. Now, before I look at anything else, that means that if this is the midpoint, that means that this segment has to equal this segment. They both got to be equal in length if this is the midpoint. And you're going to see that I'm going to need that to solve my problem, most likely. Okay, now it says that XZ, okay, XZ equals 8x minus 2. All right, so XZ, the entire thing, XZ, equals 8x minus 2. This is definitely a problem that you should pay attention. It's not really that difficult, but if you've never seen a problem like this before, you may need to look at an example, okay? So you should pay attention to this one. Okay, now YZ equals 2x plus 1. YZ equals 2x plus 1. Okay, now we got to solve for x. Now let me show you if you've never done a problem like this before, you may look at it and see a problem where you don't know how to set up the problem. You don't know how to set up the equation. Because so far, the problems that we've been looking at, we've been doing stuff like, okay, this segment right here, plus this segment right here has to equal this segment right here. The problem is that they didn't tell us what is the length of segment XY. Or at least it doesn't look like they told us, but they actually did. It doesn't look like they told us what segment XY measures, but they actually did. And I'll show you how. Because they told us that Y is the midpoint, and I mentioned that if Y is the midpoint, that means that segment XY measures the same amount as segment YZ. Therefore, segment XY measures 2x plus 1. Even though they did not specifically say that up here, because Y is the midpoint, that means that this segment has to be the same amount as this segment. So whatever they told us YZ is, XY has to be the same amount. Now I could do my problem. Now I could set up the equation. Now listen, there's two ways you could set it up. The slow way, which is fine, there's nothing wrong with this, but the slow way would be 2x plus 1 plus 2x plus 1 equals 8x minus 2. Or a faster way would be to set it up this way. 2 times 2x plus 1 equals 8x minus 2. Since I've already done several examples in this style, let me just do one in this style so you can see how that would be, even though it's simple. So first I would do the distributive property and multiply 2 times everything inside parentheses. 2 times 2x is 4x, and 2 times 1 is 2. If you would have done it this way, you get the same numbers here. Okay, so now I'm going to get the 4x to the right by subtracting 4x from both sides. On this side it cancels out. On this side it gives me 4x. And I'm going to move the minus 2 to the left by adding 2 to both sides. On this side it cancels out. On this side I get 4. So x is going to equal 4 divided by 4. So x is going to equal 1. And that's my answer. My answer is x equals 1. You're going to get a problem like that for sure on your homework. So I hope you paid attention. If you forget when you're doing the homework, just look at the video again to remember how to set up the problem. The key is knowing how to set up the problem. Once you set it up, it's just basic algebra. Okay, and then let's look at this one. Okay, so on this one, they're saying that ray SV is an angle bisector of angle RST. All right, before we continue, let me just sketch that out. Now, I don't know what angle RST looks like. It could be an obtuse angle. It could be a right angle. It could be an acute angle. It could be a straight angle. I don't know. It doesn't really matter. All right, all I need is to get a rough idea of what I'm doing here. All right, so there's a rough sketch of what angle RST might look like. Now let me get to the important part here. They're telling us that ray SV is an angle bisector. That's very important. Remember that the word bisector means that it's going through the middle. A bisector is going through the middle. So that means that ray SV is going exactly through the middle of this angle. Let me write the V here. Ray SV is going exactly through the middle of this angle. If it's going through the middle, that means that this angle has to equal the measurement of this angle right here. And you're going to see that that's a key part of the problem. That's why they're letting you know that ray SV is the angle bisector, because they want to see if you realize that that's going to separate angle RST into two equal angles. Angle RSV, which is equal in measurement to angle VST. All right, let me continue so I can show you. All right, it says if the measure of angle RSV equals 3x plus 5, RSV is equal to 3x plus 5 degrees. And by the way, the reason that they put this in parentheses is because the whole thing is measured in degrees. Like everything inside the parentheses is measured in degrees. Okay, and then it says the measure of angle RST is 8x minus 14, the measure of the entire thing. If you're paying attention, this problem is exactly like the one we just did right before it. Okay, because what they're leaving out is that they're not telling you how much this angle right here measures. They're not telling you what's the measure of angle VST, because they want to see if you realize that since ray SV is the angle bisector, That means that this angle has to equal the measurement of this angle. They're trying to see, do you know that? That means that this one also has to be 3x plus 5 degrees. So to set up my problem, I would put that this angle plus this angle has to equal what the entire thing equals, which is 8x minus 14. Or the faster way would be 2 times 3x plus 5 degrees. I won't write the degree part because you don't need it for that. Has to equal 8x minus 14. The slow way would be to write 3x plus 5 plus 3x plus 5 equals 8x minus 14. This is a faster way. Alright, so I would do the distributive property. Okay, and now I'm going to get the 6x to the right by subtracting it, which will give me 2x over here. And I'm going to get the minus 14 to the left by adding it, which will give me 24. So x is going to equal 24 divided by 2. So x is going to equal 12. Okay, and now on this one involves a linear pair. So again, let me draw a rough sketch. A linear pair will always form a straight line. Okay, now I don't know exactly what these angles look like. It doesn't matter. All I'm going to draw is a straight line and divide it into two angles. And that'll help me visualize what I have to do. Alright? This line, maybe it doesn't belong there. Maybe it belongs this way. It doesn't really matter. Okay, so we have angle ABC and angle CBD. Okay, notice that they both have the vertex on both of them is B. So B is this point right here. And they both have the C in common. So that's the side that they have in common. So this one would be angle ABC and angle CBD. If you look at the picture and look at the letters, it should make sense. Again, they both have the same vertex, which is the letter in the middle. Letter B is the vertex. And since they both have point C in common as well, that tells me that that has to be this side right here. And if you look at the angles, it works out. ABC, CBD. You could have drawn it differently, and that would have been fine. But the main thing is they both have to have the vertex B, and the ray that they have in common, or the side that they have in common, is ray BC. Okay, they gotta have this, has to be the side that they have in common. Okay, now I'm gonna use that little sketch to solve this problem. You could have done it without the sketch, but it helps us visualize what we're doing. If the measure of angle ABC equals the measure of angle CBD, okay, so I wish I would have read that first. Okay, I'm gonna leave the drawing I did there that's wrong. Let me just update it to the new and improved drawing. Okay, to show you something. Sometimes when I make a mistake, it's actually good to use to help you guys see something, because you guys are gonna encounter the same mistakes sometimes. So I kind of like it. It actually helps me sometimes to make a mistake. Alright, so look, I changed my drawing. This is the correct one, the blue one. Why? Because it says here that the measure of angle ABC has to equal the measure of angle CBD. If the two angles equal each other and they're a linear pair are two angles that equal 180. So if they're two angles that together, when you add them up, they got to give you 180. You know what? Let me backtrack. I said that wrong. I was talking fast and I misspoke. Let me say that slowly again. A linear pair are two angles that when you add them up equal 180 degrees. When you add them up, it equals 180. Now, if these two angles that when you add them up equal 180, if these two angles are equal to each other, that means that they got to be 90 degrees and 90 degrees, because that's the only possibility of two angles that equal each other that you will add up and get 180 degrees. They each got to be a 90 degree angle. That's why I changed the drawing to look like this, because they're 90 degree angles. And by the way, if you remember from the beginning of this lesson, these are perpendicular lines, because perpendicular lines form 90 degree angles. Okay, so it says that these two angles equal each other and they measure 3x minus 6 degrees. 3x minus 6 degrees. Okay, so they want us to solve for x. Okay, so the way I'm going to set this up is like this. This one's different, so look at how I'm going to set this up. First of all, let me show you how to not set it up. How's this? Let me start off with the wrong way to do it, because I could see people thinking this. In fact, in the past, there's been times that I'm doing it in a rush, and I do this, and I realize it doesn't work that way. Okay, this is wrong. I'm going to write this. This is wrong. The wrong way to do this problem would be like this. 3x minus 6 equals 3x minus 6. Yes, that is a true statement. 3x minus 6 equals 3x minus 6, but it won't allow us to solve for x. It will not allow us, because when I try to get this on one side, all I end up doing is eliminating this. I'll get 0. This side, this 3x minus 3x cancels out, and this 3x minus 3x cancels out, and I'm left with negative 6 equals negative 6, and I still don't know what x equals. So that is the wrong way to set it up, and that's a very common error. So heads up, don't do that, all right? This is wrong. Okay, the correct way to set it up is like this. This one plus this one has to equal 180 degrees. Okay, so you could either write 3x minus 6 plus 3x minus 6, or write it the faster way, which is 2 times 3x minus 6 has to equal 180. Now I'm going to do the distributive property. Alright, so I'm going to distribute, and I'm going to get 6x minus 12 equals 180. Okay, I'm going to move the 12 to the right by adding, and that's going to give me 192. Oops, 192 equals 6x. And now to get my final answer, I got to divide. X equals 192 divided by 6. Okay, when I divide that, I'm going to get x equals 32. That's my answer. So again, the most important part is knowing how to set up the equation. Once you get that right, the rest is easy. You will have a problem like this on your homework, so definitely take note. If you get to the homework and you forget how to do that one, look back at the video. Again, the wrong way to set it up would be to put 3x minus 6 equals 3x minus 6, because that does not allow you to solve for x. You have to set it up this way. Because it's a linear pair, when you add a linear pair, it always equals 180 degrees. So you could have either written 3x minus 6 plus 3x minus 6 equals 180, or the shorter way, which is 2 times 3x minus 6 equals 180, and use that equation to solve for x. Okay, and that concludes today's lesson. Your homework assignment is in the student portal, and it's due before 6 a.m. the next day that you have me.